Hello, welcome to Chapter 7, Section 7. We're doing the guided practice problems on page 497, where we're going to be multiplying polynomials. So in this example, we're going to be doing some binomials times trinomials, and maybe some other things are going to show up too. As always, you can do this by making a multiplication chart. Let me show you what I mean. So this multiplication chart, I'm going to put x plus 5 right here, and I'll put x to the second power, 2x, and 3, pull that over a little bit more, across the top. Oh, and sorry, that's plus negative 2x. I didn't look at that negative sign. All right, so I'll do it this time, but I probably won't do it for the rest of them. I'll fill in the rest of the grid lines so you can see what I'm actually talking about. And that way, when I do that one, I can show you back and forth. X times x to the second power is x to the third power. X times negative 2x is negative 2x to the second power. And x times 3, 3x. 5 times x squared is 5x to the second power. 5 times negative 2x is negative 10x. And 5 times 3 is 15. So I've got a 2 terms binomial by 3 terms trinomial. 2 times 3 equals 6. I've got 6 terms in here. Some of them have the same exponent, x to the second, and x and x. So I'm going to be able to put these two together and these two together. So my simplified polynomial is going to be x to the third, that one. 5 subtract 2 is 3, so I get 3x to the second power. Negative 10 plus 3 is negative 7x plus 15. Now for this one, I'm going to do the same problem, different numbers. I'm just not going to fill in the entire grid. So 3x plus 4, I'm going to write right there, x to the second power, negative 5x, and 2. 3x times x squared is 3x to the third power. Sorry, I gotta do something real quick. 3x times negative 5x is negative 15x to the second power. And 3x times 2, 3 times 2 is 6, so I get 6x. Going across the second row, 4 times x squared is 4x squared. 4 times negative 5, x is negative 20x. And 4 times 2 is 8. So now again, look at it. These two are like terms and these two are like terms. So I get 3x to the third power. 4 subtract 15 is negative 11x to the second power. Negative 20 plus 6 is negative 14x plus 8. So 2x subtract 4, I'm going to put here. Negative 3x to the third power, 2x, and negative 5. 2 times negative 3 is negative 6. X to the first times x to the third is x to the fourth power. 2 times 2 is 4. X times x is x squared, so I get 4x to the second power. 2x times negative 5 is negative 10x. Now let's do the second row. Negative 4 times negative 3 is positive 12. There's no x's here, so I just still get x to the third power right here. Negative 4 times 2x is negative 8x. And negative 4 times negative 5 is positive 20. Now let's look for like terms. See, because I didn't have that's an x to the third power and I don't have an x to the second power, things are not going to be lined up. I actually have 0x to the second power here, which I usually don't show. So let's see what we have. We have x to the fourth. Don't have any more of those, so I get negative 6x to the fourth. Here's x to the third, but I don't have any more, so plus 12x to the third. 4x squared, nothing to add to that. But check this out, I got negative 8x and negative 10x, so I get negative 18x plus 20. Number 22, I get negative 4x plus 6. And across the top, I get 2x to the third power, negative x to the second power, and 1. And when I combine like terms, notice I don't have any x to the first power, so I have to be mindful of that. Negative 4 times 2 is negative 8. 1 plus 3 equals 4, so I get x to the fourth power. Negative 4x times negative x squared is positive 4x to the third power. And negative 4x times 1 is just negative 4x. For the second row, I'm going to multiply all these by 6. 6 times 2 is 12, so I get 12x to the third. 6 times negative 1 is negative 6, so I get negative 6x to the second power. And 6 times 1 equals 6. So where are my like terms? Negative 8x to the fourth. No more x to the fourth here, but these two are x to the third. So 12 plus 4 is 16. I have x to the second power. I have negative 4x and plus 6. Nothing else is going to combine. Alright, hopefully the rest of these are going to be a little bit easier than that. Here's x, subtract 5. And across the top I got x to the second power, x, and 1. So x times x to the second power is x to the third power. X times x is x to the second power. And x times 1 is just x. Negative 5 times x squared is negative 5x squared. Negative 5 times x is negative 5x. And negative 5 times 1 is negative 5. Now for this one, because it wasn't missing anything, like up here I was missing an x to the second power, and here I was missing just x to the first power. Nothing's missing here, so I have everything filled in. These are like terms, and so are those. So I get x to the third. Negative 5 plus 1 is negative 4, so negative 4x squared. Negative 5 plus 1 is also negative 4, so negative 4x. Subtract 5. Alright, finally for problem number 24. I have a binomial times a binomial times a binomial. Remember we talked about the associative property means that when I'm multiplying more than two things, I just do them two at a time. So I'm going to start, and hopefully I got enough room in here. I'm going to start by doing a plus b times a minus b. So I get a squared, subtract ab, excuse me, I gotta get some water, and negative b squared. Well, that's actually kind of cool because these two add up to 0. ab subtract ab is 0. So this is just a to the second power subtract b to the second power. So I ended up not getting a trinomial, I got a binomial because the middle term dropped out. What's cool about that is that this a plus b times a minus b, we call this the difference of two squares. And I'm mentioning that because I'm setting you up for when we are factoring. We'll see that again later in chapter 7, but I'm also trying to set you up for when we get into factoring. We'll say, can we factor that? And you just remember the pattern. Okay, but it comes from this. But I'm going to take that a squared, subtract b squared, and I'm going to multiply that by b subtract a. So a squared times b is a squared times b, obviously. A to the second power times negative a is negative a to the third power. Excuse me. Negative b to the second power times b is negative b to the third power. And negative b to the second power times negative a, negative times negative is a positive. Put the variables in alphabetical order, a, b to the second power. None of these are like terms. And we get into a little confusion about the order. I probably want to go in the order from the a's. So I would do this one, then that one, then that one, then that one. Don't panic about that. I get a squared b, subtract a to the third power, subtract b to the third power, plus ab to the second power. All right, we'll see you in the next video.